Welcome back. In this video we're going to cover the process of backing up and restoring a SQL Server database. The process of backing up a database can be defined as backing up the operational state, architecture and stored data of the database software, with the primary goal of reducing data loss in case of any accidental or deliberate loss of data. These processes occur within the context of the recovery model of the database. Before we take a deep dive into recovery models, we're first going to try and understand what the transaction log is, for it plays an essential role in data recovery. The transaction log is a sequential record that records all transactions, and the database modifications made by each transaction. When we perform operations against the database, SQL Server will first check if the data pages of the data to be changed are already in the buffer cache. If that's not the case, SQL Server will then load the clean data pages from disk into the buffer cache. These data pages will then be modified, resulting in dirty pages. If the buffer cache or log buffer becomes full, the data changes will be written to the transaction log on disk. At a later transaction checkpoint, the log buffer flushes the transaction log and writes the dirty data pages permanently to the data file on disk. At this point, the transactions will be marked as completed. If the system crashes for some reason, while there were unpersisted changes, the database will be left in an inconsistent state. This is where the transaction log comes in. If the system is operational again, SQL Server will check the transaction log for transactions that haven't been completed prior to the system failure. The data changes that haven't been persisted to the database on disk will then be persisted, therefore bringing the database back to a consistent state. This is just a high-level overview of the transaction log to point out the important role it plays in terms of data recovery. Let's now look at the recovery models. A recovery model is a database property that controls how transactions are logged, whether the transaction log requires and allows backing up, and what kinds of restore operations are available. In SQL Server we have three recovery models available. First we have the simple recovery model. With this model, the transaction log is truncated on a regular basis, and therefore saves log space. But it comes with great risks. When we use the simple recovery model, the transaction log is truncated every time the database reaches a transaction checkpoint. If for some reason the system crashes, you won't be able to restore the data to a point in time right before the system crashes, because there won't be log records in the transaction log to use. The only thing you'd be able to do is restore the database using a full or differential backup, which we'll cover in a second. This means that any data changes that were made between the time of a full or differential backup, up to the time of the system crash, will be lost. That's why this model should only be used if data loss is acceptable. Secondly, we have the full recovery model. This model allows you to restore to a point in time, because all the transactions are fully recorded and preserved in the transaction log, until a backup is made. This is the default recovery model when we create a new database in SQL Server. If a system failure were to occur, we'd be able to restore the data to the point in time right before the failure occurred, therefore, undoing the effects of the error. So basically with the full recovery model, no work is lost due to a lost or damaged data file. The problem with this model is that the transaction log keeps growing, and might eventually become full, which requires some maintenance on our end. Last but not least, we have the bulk logged recovery model. This model is a compromise between the two. It allows good performance while using the least log space. It is also the least used recovery model. This model uses a technique known as minimal logging. This means that only the information that is required to recover a transaction is logged, and therefore reducing the possibility of bulk operations filling up the transaction log. However, due to minimal logging, this model does not support point-in-time recovery. Knowing the recovery models, we're now going to look at the three most common types of database backups we can make in SQL Server. First we have the full database backup. As the name suggests, this is a complete copy of the entire database, including all data files and the active part of the transaction log. This type of backup allows for the simplest form of database restoration, and can be easily used to restore a database in exactly the same form as it was at the time of the backup. A full backup must be done at least once before any of the other types of backups can be run, and therefore forms the basis for every other kind of backup. Then we have the differential backup. This is a backup of all the changes that have been made since the last full backup. As you can see in the image, if we create a full backup on Sunday, and a differential backup on Monday, that backup would contain only the changes that have been made since Sunday. If I now create another differential backup on Tuesday, that backup would also contain only the changes that have been made since Sunday, but would be relatively larger than the one we made on Monday, because it now spans over 2 days. This is also the same if we create another differential backup on Wednesday. Differential backups are generally quicker than full backups, because so much less data is being backed up. Noteworthy of differential backups is that the amount of data being backed up grows with each differential backup, until the next full backup. As can be seen in this image. Finally, we have the incremental backup, also known as the transaction log backup. This type of backup contains all the changes that have been made since the last backup operation. So if we, for example, create a full backup on Sunday, and an incremental backup on Monday, that backup will only contain the changes made since Sunday. If we now create another incremental backup on Tuesday, that backup will contain only the changes that have been made since Monday. So unlike the differential backup, the incremental backup creates a backup of all the changes since the last backup, regardless of whether it was a full backup or not. Since it only backs up the transaction log, it runs a lot quicker than a differential backup, and allows for a point-in-time restoration. Let's head over to SQL Server Management Studio to create our first backup. First, we're going to look at how we can configure the recovery model of a database. To do this, we're going to head over to the Object Explorer and look at the properties of the database. We can then head over to the Options section. Here you'll see a number of database configurations we can change, including the recovery model. Here we could, for example, change the recovery model to simple, or bulk logged, but we're going to leave it to the default. Another way to do this is by using Transact SQL. We would then alter the database and change the recovery model property of the database to what we deem appropriate. Let's close this for now. To create a backup of a database, we can right-click on the database, and select Tasks. We can then choose to create a backup, after which the following window will appear. Here you'll again be able to see the recovery model of the database. The next thing we can do is configure the backup type. For now, we're going to leave it as a full backup. We still have one thing left to do. We need to select the destination for the backup. Since I already had a backup created for this database, I'm going to remove it, so we can start from scratch. To add a destination for the backup, we can click on the Add button. Here we can browse for the destination directory. We can either choose to leave it to the default directory SQL Server uses to store backups, or choose our own by using the tree list navigation. To keep it simple, I'm going to use the default directory, and name the backup file, Fundamentals. Don't forget the .back extension. Once we've finished configuring the destination, we can go ahead and create the backup. If the process is done, we get a message stating that the backup of this database has been completed successfully. Let's say during some database routine or activity, one of my colleagues accidentally deletes one of the tables. Specifically the track table. We would now have 3 tables instead of 4. This is a database that stores music information, but if it was a database related to a core banking system, you can understand the ramifications this would have. Luckily for us, we created a database backup, which we can easily use to restore the database to the exact point in time we created the backup, which was before the table got removed. To restore the database, we can right-click on the database, and select Tasks. Here you'll see a Restore option. If we select this, you'll see a number of things we can restore. For now we will only focus on a database. First thing you'll see is the full backup we recently created, and that's because we used the default directory. If we hadn't used the default directory, we would need to select Device. And then click on the Browse button, then we get this familiar window. We can now click on the Add button to open the browser window, to search for the backup file. Mine is right here, so I can simply select it. Since I have used the default location for backups, I'm going to switch the source back to database. Now let's go ahead and restore this database. Once the restoration process is done, we get the following message, stating that the database is successfully restored. If we now go to the Object Explorer, and refresh the Tables node, you'll be able to see the track table, unharmed, exactly as it was at the time we created the backup. We've now covered the fundamentals of backing up and restoring a SQL Server database. This video marks the end of this course. Thank you for being a part of it. In the next video I'm going to cover some resources you can use to further your knowledge on the exam objectives, and the practice questions you can use. See you then.